start with DC footing. And I have already created a new project. We want to see the those parameters here. And yeah, first, like, we have the analyzer standards, and it's the same as in DC repo. And I just want to give a short introduction here. You have the German standards here, like the old standards, the standard for Switzerland, and the EC7. We have different national standards here, national standards for the Euro code. And yeah, like Germany, Austria, France, like UK, Italy, and Spain. And yeah, there's the opportunity to add any of our national settings if you want. And yeah, when we close this window, we can see the predefined partial safety factors. We cannot change them manually. We must choose one national standard here, or you have you can define a different standard if you want. And then you can make some additional settings for the earth pressure over here, and the tensor 4085 is selected standard way, like we mainly use it here in Germany here. And then you can also make some settings for the safety factors for the overturning check over here. And you can, edit the G, like, for the overturning check then. And the last setting is the one for the dimensioning. You can choose the Eurocode 2, like with different national settings, it's the same as over here. And Germany is selected, or you can choose the old German standard or the Switzerland standard, Austria or British standard. Yeah, we'll say OK. And then we offer two different analysis approaches. The first one is the section forces at the base, which is like dimensioning the typical foundation. And the second one is that we can have a fixed footing according to Steckner. I will explain this later. Then we can set the application for the self-weight and for the earth pressure here. Then we are ready. Yeah. Yeah, we must enter a name. Fine. And I want to show you the views. With this icon, you can see all views, like for different, like XZ axis, YZ, XY, and the 3D view, which is nice to see the soil pressure. But we go back to the XZ view, like this is like the standard view, like the Z axis and the X. Yeah, there's created one foundation with one soil layer, and when we double click on a foundation and edit it. I will start with the foundation, with the dimensions, and you can choose between rectangle, strip, and circle. And when you choose a strip foundation, you can also add a foundation slab, or you can have cantilever footing here. And we can also, like, here's a circle foundation then, but we choose the rectangle foundation now. And we can activate the optimization. And you can have this for all directions, X, Y, and Z. And you can choose if it's like in which direction it should be optimated, like centric or like plus and minus direction. But we don't choose an optimization right now. I will show this later. Yeah, we enter the data here. We say the bottom edge at -1, the width of 3 meters, and in the other direction 2 meters, a height of 1 meter, and the hour stays the same. Then we can enter a column and a model sleeve if we want that. And we can activate a punching verification in construction stage. The next one is the design. We choose a concrete grade of the C2025 and for the reinforcement of 500B. Then we can change the spacing of the reinforcement bars if you want this. Yeah, and there are several other options available, like that we just check the footing without the reinforcement, the application of minimum reinforcement. Yeah, you can choose this here. The next one is the punching. You can, increase the reinforcement for the punching verification if it's necessary. Like if you think it's necessary, you can do this here. And then the last one is that we choose the verifications which shall be run. Sliding stability, bearing capacity, settlement, permissible soil pressure, and like you can say on, off, or if you want this, but we want all verifications in this example. We say okay, and the next step is to edit the soil data. We can have multiple horizontal soil layers, and the first one is a loose soil. So we double click here in the first layer, and we want to have a loose sand. We want to have a loose sand, which is here. And we use the parameters adjustments here, so the parameters are filled out automatically from the symbol editor. And this is the first one. And with this icon here, layers, we can add other layers. So the second one is from 2 meters, and we choose a semi-solid clay. Say apply. The parameters are here. Say okay. And then the third one from 3 meters, and we have a middle dense sand. Okay, apply. Okay, so we have 3 layers. And each layer has a different color, like sand is the same color, obviously, but the clay is purple. And when we see the symbol editor, then you can see, like it's in German here now, but you can see that each soil type has its own abbreviation and the name. And when you say we go to the clay, then you see that it's purple here. So when the program recognizes a predefined soil type, it the color is filled out automatically from this information. You can add new soil types, or you can edit the existing ones. Then we can move on to the to the loads. And you can add different load cases with vertical, horizontal loads, and like from different directions, and bending moments. And there's the opportunity to enter bending moments from the theory of second order over here. And then we have a first load case, which is a dead load. And we have a vertical load of 300 kilonewton. Then we add a new load case, a live load. We choose this one here. And we have 20 kilonewton in y direction. And then we have 500 kilonewton and a bending moment of 50. And we have a category of office use. Right? And then we have a third one, which is wind. And we have a horizontal load in x direction of 35 kilonewton and no vertical load, and a moment in the y-axis of 90 kilonewton meter. And we say the category is wind. Okay. Then we use the design situation permanent for all load cases for the complete situation in general. And yeah, what we did is that we have chosen a load category. And each load category has its own C values according to the Euro code. And you can choose the category each year. And yeah, and the C values are filled out automatically. So you can see here the wind has different C values than the live load over here. Yeah. And a single load is the action from horizontal and vertical load and the bending moment. And the load case summarizes the related actions, and the program does the load case combination for all load cases automatically later. You will see this in the results. Yeah. Say OK. So you can see the loads here. And then we can add excavation stages if we want. And yeah, you can add different excavation stages with slopes at the top surface, and you can add a water level in this window. Oh, okay. I must activate it. Yeah, here we go. Like you can add a slope and you can add a water level, but we want to have a flat top here. Okay. Yeah, then we can start the calculation. And yeah, with this icon, you can also choose the reinforcement bar diameters if you want to change them, but it says here with 16 millimeter. And then we can see the results. And then you can see the information about the design approach, the footing dimensions, the soil layer data, the concentrated loads. The next page. You can then see the partial safety factors. And then we can see here a table for the case combinations for the ground analysis, and then for dimensioning as well. Then in this table, the results are summarized for each load combination, load case combination, with all the results. And the critical results are shown in this table separately. And the same is for the reinforcement, that the amount of reinforcement is shown for each load case combination, and the critical results are shown here. Yes. Then the verifications for the ground analysis are shown in details here for the overturning, for dead loads and total loads. Both are fulfilled here. And then the verification of equilibrium is fulfilled as well. Then we have the soil pressure, sliding stability, and which is also like a very small utilization. And then we have the bearing capacity, and we just see that the utilization is quite small, like with 0.47. So we can optimize it later. And then here we have the settlements here below each corner, and the maximum value is 2.7 millimeters. Yeah. Then on the next page, we can see the graphic with all load cases, the foundation. This is like the one view, and this is like the top view, the side view, and all the relevant results are summarized. And on the next page, you can also see like the overview, side view, and you can see the ground failure feature. And this is obviously the relevant direction for the ground failure feature. That's because it's just shown in this one. And yes. And the last page is the last page is the design of the reinforced concrete according to ECC 2. And you can see the critical sective forces, and then you can see the required reinforcement. Yeah. And the summary over here shows that our calculations are fulfilled. Then we go back to the input window, and then we can see in the 3D view that the soil pressure and the loads are shown now here. Yeah, it's a nice overview to see everything like loads, foundation, and the soil pressure. Then we go back to the XZ view, and now we want to optimize the foundation in X and Y direction. We activate this, say OK, we calculate again, and we go to the results. And now you can see that the width and our transfer width is smaller, like 2.7 meters instead of 3 meters, and 1.7 meters instead of 2 meters. And then we go down to the results, the critical results here, and the bearing capacity, like the most critical one is 0.85 instead of I think it was 0.47, and the settlements are a little bit greater now, like 0.6 millimeters more. And yeah, everything is still fulfilled, and the foundation is optimized. Great. Yeah, go back to the input window, and yeah, now we want to have a look on the second design approach, the fixed footing according to Stegner. yeah, this is like additional option to DC footing. It's DC pylon footing, which can calculate fixed blocks and pylon footings in accordance with the method by Steckner. It's published in 1989. This approach proves the serviceability and stability verifications for the pylon footings. And yeah, but it's important to know that the method by Steckner is an approximate solution. And yeah. So the method says that, like, in the method, we have like one footing, and this footing is applied with a bending moment as a main action. And due to the rotation from the bending moment, the earth pressure is activated, and like hence the footing is fixed through the active and passive earth pressure. The serviceability verification is proved with the inclination of the footing. A bending moment is determined with the given permitted inclination tangents alpha. If you say, which is given then here, which you must enter, or like it stays the same here. And this bending moment from the permitted inclination must be greater than the action. Like the inclination due to the action must be less than the permitted inclination. And for the stability verification, an ultimate bending moment is determined. And this ultimate bending moment is the result of all forces applying on a footing due to the inclination, like the rotation. So this includes active and passive earth pressure, bottom friction, soil pressure, and this ultimate bending moment will be compared with the applied bending moment. So yes, this is like the actual method. So we have switched to the fixed footing, and you can predefine a bending coefficients. If you don't do this, it is determined with the friction angle and the dimensions. And then we can also activate the reduction of mobilized earth resistance according to DIN 1054. Yeah, 54. Yeah, and we say it's okay. We have the foundation. Then we want to edit the foundation. We say this is off now. Then we have a bottom edge at -2. Then we want to have a little bit smaller, 1.5, 1.5, and a height of 2 meters. Yes. Okay. Then, yeah, design approach stays the same here. Yeah. Yeah. Then we want to edit the soil layers. We just want to have 2 layers. The first one shall be a mid-dense gravel. Right. Okay. The second one is a middle-dense sand. Right. From a depth of 2.2 meters. Okay. Then we adapt the loads. We want to have just one load case. Make it a little here now for this example. And we have 1 kilonewton in both horizontal directions, 1 kilonewton vertical direction and my of 100. We said, okay, we have made it like the bending moment, which is like the main action here. And with this main action, the routing will rotate then. We can calculate it. And now we can see the results. All the information about the dimensions and soil data, the concentrated loads, and the load case combinations. And then we have the verifications. Yeah, so the first one is the serviceability limit check, and the resulting bending moment due to the inclination is greater than the bending moment, like the 100 kilonewton bending moment, which is like the main action, is less than 169 kilonewton. So the verification is fulfilled because this is greater than the applied bending moment. Yes. And then the stability analysis shows that, like, this analysis is with partial stability factors. So we have a design bending moment, which is with 135 kilonewton meter, and the ultimate bending moment, which is calculated with all the forces which act like comes from the direction of the rotation, and this ultimate bending moment is also greater than the design applied bending moment. So this verification is fulfilled as well. And on the next page, we can see the graphic. Like, we have two ones, and this is like the relevant one, because we have like the bending moment in this direction. So on this graphic, you can see all the forces which comes from the rotation, like the earth pressures here and the soil pressure, and all forces together will like all forces together, like the ultimate bending moment is the result of like all those forces rotating on the footing. Exactly. Yes. And then we have the design of the reinforced concrete according to EU Code 2, and we have the required reinforcement, and then we have the summary that all calculations are fulfilled.